all of this before and actually done this himself, is our Bigfoot Network's Killer E2100 networking on the G1-Killer motherboard. What we have here, right here, is a G1-Killer motherboard with E2100 networking, and it's running, or it's just recently run the Final Fantasy XIV benchmark. Underneath that, it's also running a little client that's sending 100 byte packets every 50 milliseconds to the server over there. Over here, over our Gigabit LAN to the server over there. Over here we have a competitive motherboard that is identically configured, the same graphics, same CPU, same RAM, even the same CPU cooler, only it's got the standard Windows network. It also is running the same client, sending 100 byte packets every 50 milliseconds over the Gigabit LAN to this server. That's actually the monitor for that machine right there. The server then is decoding the latency between those packets. And what we see here, the red line, is the steady, flat, very low latency, about 790 microseconds of the Killer E2100 on the G1-Killer motherboard. And then there is that black line is the rather random and extremely high latency of the standard network card on the standard networking hardware on a competitive motherboard. What this demonstrates is that, especially when it comes to gaming, that precision is key. We've run dozens of this test throughout the week, and what you'll see here is that these are just screenshots of earlier tests. We've got we've got 790 microseconds as our mean latency there. Got 792 microseconds as our mean latency there, while the mean ping for the competitive motherboard is not only anywhere from 400 to 600% higher, but also look at the numbers here for the worst 10%. The worst 10% of our performance is within about 1/10% of our mean performance, right? So in this case, 791 microseconds versus 800 microseconds. So in their case, their average latency is 4 milliseconds versus average peaks up around 29 milliseconds. At 60 frames a second, that's almost 2 frames, right? At 120 frames per second, like what pro gamers like to play at, that's almost 4 frames. So you can see here that on average, we're 415% faster, but we have 156,000% less jitter, right? Which means we're that much more precise than a high-powered standard networking motherboard. Same here, 600% faster. While their mean latency is around 6 milliseconds, they have spikes of around 39-40 milliseconds, right? Where our mean latency is 792 microseconds, our worst 10% is still 800 microseconds. So we're 600% faster with 341,000% less jitter. Right? So we're much more precise, and what precision offers a game developer is the knowledge that they'll always get the packet that they're looking for at the right time. As more killer technology arrives on more motherboards, more game developers will be able to offer richer experiences because they're less reliant on the random nature of Windows networking and more reliant on the precision and speed of killer networking. And that's better for all gamers.